let's get on with it. We've been talking about probability the last 2 weeks now. And finally, we get to the end where we can actually do some real meaty questions, okay? Before we start with the calculations, just a reminder about the formula. So the formula is P, the probability. You find it by looking for your observed outcomes, what you're looking for in the experiment, out of the total possible number of outcomes you can get in this experiment. So it's what you're looking for out of all the possible outcomes that you can get. Okay. All right, let's get stuck in. We've used this formula a couple of times already, but there it is for you. If you want to just remember it or take a screenshot of it, we're going to use this formula a lot tonight. Tuesday, we did tree diagrams and we looked at a two-way table. We're going to put that into practice tonight as well. Okay, here is the first scenario. There's a lot going on here. Let's read it together. So it says, Bafana and Bafana are going to play 3 soccer matches in a round-robin tournament. Before each soccer match, the captains of the teams flip a coin to determine which team will have the kickoff. So obviously you flip the coin, and if you win the coin toss, you get to have the kickoff. That's the scenario here. Question A. What is the probability of having the kickoff every time if Kune always chooses tails? He chooses tails every time. What's the probability of having the kickoff every time if he chooses tails? Now, I'm going to come back to this question, but let's look at question B, because looking at this question, you might be thinking, oh my gosh, where do I even start? All right, he's going to do it 3 times. He always chooses tails. What's the chance he's going to kick off every time or win on tails every time? All right, now, just looking at that question, question A on its own, can be quite challenging, but we've learned to draw diagrams to help us with this. So let's do B first. It says, question B says, draw a tree diagram to represent the possible outcomes of all 3 coin tosses, and then use a tree diagram to answer the questions that follow. Well, we're going to use a tree diagram to come back to A. Let's get the diagram out first, and then we can answer, like we learned on Tuesday, we can answer any question we want. Okay, now, you guys are going to do it, and then I'm going to do it, and we're going to compare what we have, and then we'll start answering questions from there. So please go ahead and start to draw a tree diagram for 3 coin tosses, one after the other. Remember, when you toss a coin to start off this tree diagram, how many options are there? 2. Heads or tails. So let's say heads is H and tails is T. Okay, so those are your options, heads or tails, to start off this tree diagram. Okay. The answer would be never. Oh, you said that. Yes. We're patriotic, but we're also real. We're realists. We're patriotic, but we know. Bafana, eh?
Nah, we
That
have to
story.
keep real all the time.
Yeah, we've got to be real, guys. We're dealing with a lot of realities in our country at the moment. Let's be real. Okay. Let's be real and deal with reality. All right, so please go ahead, draw that tree diagram. Should take you about 2-3 minutes, and then we're going to compare, and then we're going to answer all these questions. All right, off you go. All right, I see people working there. All right, Nawal Boyson, you working hard there? All right, good. Everyone's
Ooh, we
working.
got a smile.
All right, good. Everyone should be drawing a tree diagram, not looking at the screen. Everyone should be drawing a diagram, and we're going to compare your diagram with my diagram. Remember, this is not Netflix. You guys are going to do work tonight. All right, so let's see. Tree diagrams. Lauren. So, yeah. So wait for the first question when we do this one, and then you might get a tree diagram in the next one. But we did tree diagrams on Tuesday. If you really want to go back and see how we did it, then the best thing to do is to go to Watobe's YouTube channel after this lesson and go back and check that lesson out where we drew tree diagrams and we dealt with two-way tables as well. But just wait for question B to be done, and then I'm sure you can answer A, C, D, and E after the tree diagram. All right, so don't stress about it. But everyone that was here on Tuesday should be drawing tree diagrams. There should be some beautiful trees on your paper there. All right, it should be almost done. I hope you guys have got something on your page. It's important to try this out to practice. So when you get to the exam, you don't have this feeling of, oh, I don't know where to start, or I don't know what to do. You practice now and you'll be confident in the exam. That's why we do this. Excellent. Well done. Some people have finished. All right, let's get cracking with our tree diagrams. All right, so I'm going to draw it underneath here, and then I'm going to move it up to the top right-hand side so we can do the questions. So let's start here at the bottom. So they toss the coin 3 times, right? The first time they do it, there are only 2 options. You can get heads or you can get tails. So there's 2 branches, heads or tails. If they get heads the first time, right, and then they toss the coin again, there are only 2 options. They can get heads or tails. If they toss the coin and get tails the first time and then toss it again, they can get heads or tails. All right, now I need to move down a bit. Spacing is always an issue with these things. Now, this is the first coin toss. This column here is the second coin toss. All right, now after the second one, let's say you got heads the first time, heads the second time. We're sticking on this branch here. Again, you toss the coin, and again, there are 2 more options. You can get heads or tails. For this one, again, 2 options, heads or tails. And for this one, again, 2 options, heads or tails. And I'm sure you guys will struggle with spacing. Everybody does. All right. Sometimes they go skew, like mine. It's okay. As long as we have all our options here. This is the third coin toss. All right. Now, like what I said, there's something missing here. Well done. All those people saying don't think fantastic. There's something missing in my diagram. Very important. Well done, Sonia. What's missing in my diagram, guys? I hope you guys have it in your diagram. Something's missing in mine. Who can tell me what's missing? I told you guys on Tuesday, you have to have this in your diagram. It's not complete without it. The results, the outcomes. Very good. Well done. So in brackets, we're going to write all the results, okay? The outcomes. So H, H, H for that first branch. Second branch, we got an H, then an H, then a T. HTH, like the chemicals for your pool. Then HTT. Then THH. Then TTT. Oh, sorry. I'm getting going. THH, I've got THT. THT, and I need to move it up slightly. So let's put it here. THT. I'm trying to keep these in line with the branches. If they're not, it's not a train smash. They're not going to penalize you if your bracket isn't exactly in line with the branch. They just want to see all your outcomes. Okay, so TTT is the last one. All right. There we go. All right, as in line by line, yes. Okay, so there are all our outcomes. Now we can answer any question once we have this thing here. So let's go back to the first one. Remember how you felt when you saw the first question. All right, let's have a look. Question A. What is the probability of having the kickoff every time? In other words, winning the coin toss if they choose tails. So they've got to choose tails and win. It's got to land on tails every time. Where do we see that? Only here at the bottom. What is that probability? Well, let me quickly do this one, and then you guys are going to do the rest. Okay, so for A, the probability of getting tails and then tails, and then tails is equal to 1 out of, everyone should have it, 8, because there are 8 total possible outcomes here. All right, and the question didn't say exactly. The question didn't say leave it as a fraction or leave it as a percentage or leave it as a decimal. Now, if they don't ask for a fraction, a percentage, or decimal, you leave it as a fraction, okay? Because the person that's marking wants to see the 8 and they want to see the 1 in your fraction. That's what they're looking for. All right, so just leave it like that, okay? All right, who's going to help me with question C? Somebody.
Anybody.
Anybody.
Somebody.
Somebody. Question C, who's going to help me? Raise your mighty hands. Raise your mighty hands. Come on, where's my people? Where's my go-to people? What about Bianca? Let's see if Bianca will answer us. Hello, Bianca. Sadima.
Hi, sir.
How are you?
I'm good, sir.
Good. I'm glad you're good. Then you can help me with question C. Question C says, what's the probability of winning all 3 coin tosses if he chose heads, heads, tails?
Heads, tails. Huh. Okay, let me see. I think it's 3/8.
All right. Now heads, tails. Okay. So now what Bianca's doing is she's going to that one. She's going to that one. And then if Teacher Dale's writing was clearer enough. Yeah. Sorry, guys. You would see that that's also an H. So I think Bianca's looking at these 3 here. Okay. Now,
yes,
when they ask these questions, they have to be specific because sometimes it gets confusing. Are they asking for heads, then tails in that order? Or are they asking for 2 heads and a tails in any order? The question has to be specific. They're not very clear in this question. Hey, Bianca.
they're not.
They're not. You're right, they're not. I think they might be specifically looking at an order because we got commas here. You see, you got H, comma, T. I think it means
Yes.
first the H, and then another H, and then the T. So I think they are order specific here. So we're looking for one that's H first, and then a H, and then a T.
But it should have been specific.
You're right.
Jesus.
You're right, Bianca. You're right. In the exam, the examiner has to be specific. So they will either say in any order, or they'll say, what is the probability of winning all 3 coin tosses if he chooses HHT consecutively? They might even use the word consecutively, which means one after the other in that order. Okay, let's pretend it is consecutive. Let's be specific for them. Let's pretend it's consecutive. Then how many times will we see an H and then a T?
1 times.
1 time. So it's 1 over?
1/8.
Very good. Thank you, Bianca. Excellent. Good job. Well done. Well done. All right. Yes. Yes, Sakila, I agree with you. I think there is an order. They've got to be specific. Okay, I think the comma is trying to tell us that there is an order. They should say the words in any order, and then we're going to do what Bianca did and pick 2 H's and 1 T, which is 3 of them. That's why she mentioned 3. All right, so I think the commas mean consecutive in this instance. If they're one in any order, they should say in any order. All right, very good. Okay, now question D says, what is the probability of winning all 3 coin tosses if Kuna chooses THT? All right, so let's pretend that is consecutive. The question is, if you write down HHT, will you lose if you do or if you don't? Are you referring to in the probability here, Tabele? Are you referring to these letters that I wrote in here? If you don't write that, no, you will not lose a mark. It's just me showing you what we're looking for. Okay, so if you didn't see the question and you only looked at this statement that I made here, you would know what we're looking for. Because if I don't, especially if I'm writing for you guys tonight, if I don't and I leave these out, those answers look exactly the same. Exactly the same. So with that text there in the brackets, I'm just being specific and showing you exactly what we're specifically looking for. It's just repeating what the question's saying. All right, don't worry about it. You will not lose a mark if you don't put that there, okay? But another reason why I'm showing you this is they sometimes will actually maybe write the question like this. For example, they'll say, find P of T. And you need to know what that is. So the probability of getting tails, like in this situation. All right, so the notation that I'm using here, I'm trying to get you guys to get used to it. So if you do see it, you understand what it is. All right, but no, you don't have to write it down. You're not going to lose a mark. All right, question D. What is the probability of winning all three coin tosses if Kuna chooses tails, heads, tails? We're assuming it's consecutive again. There's only one place that this happens. Yes, come on, well done. Only one place this happens. If it's consecutive, there's only one place. Again, 1/8. They're not asking for percentage, decimal, or anything else. We're just giving them fractions. Okay. If it wasn't consecutive and it's in any order, we need two tails and a heads. Then we'd be looking at that one and also this one. So there would be 3, like Bianca said earlier. All right. So if they say in any order, there's 3 that we need, but we're pretending it's consecutive, which is only the 1 out of the 8. All right. Who wants to help me with question E? Very good, guys. Well done. Now, this is a challenge. Who's up for the challenge? Where's Emmanuel? Emmanuel, are you up for the challenge? Who's up for the challenge, guys? Raise your hand if you're up for the challenge of question E.
Good afternoon, sir.
Emmanuel, how are you?
Good, thanks. And how are you?
Good, thank you. Emmanuel, do you want to try E?
Yes, please, sir.
All right, let's read it. It says, what is the probability of losing all 3 coin tosses if he chooses tails every time? Now, we've seen this text before. If I scroll up a little bit, question A said, what's the probability of having the kick up every time or winning every time if he chooses tails? All right, so we answered question A over here at the top. Now they're asking us, what's the probability of losing 3 times in a row if he chooses tails, tails, tails? How are we going to do that? So the probability of winning if he chooses tails, tails, tails is 1/8. What's the probability of losing if he chooses tails, tails, tails? How are we going to get that?
His mic went
Yes.
off.
Yeah, he's
Yes,
back.
sorry for that.
No
So
worries.
the possibility is also 1/8 because there's only one event that occurred whereby it was all tails.
You're right. So if he chooses tails, all right, he's going to win. You're absolutely right. So we answered that in question A. So we said the probability of tails, tails, tails is 1/8. Now listen carefully. They're asking you here, what's the probability that he will lose or not get that? How many times do you see in this scenario that he will not get tails, tails, tails?
So please rephrase it.
So we see tails, tails, tails once out of the 8 possible. Do you agree with me?
Yes, sir.
Okay. What's the probability of not getting that? In other words, getting everything but that. I'm giving you a big clue there. I'm getting everything except for that one. Because we see tails, tails, tails once like you said. So what's the probability of not getting that? How many times in this experiment, Emmanuel, will you not see tails, tails, tails?
7 times.
Exactly. All right. Very good, Emmanuel. So if I say probability of not tails, 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 there are 7 times that it wasn't tails, tails, tails. All the others, it's 7 out of 8. Thank you, Emmanuel.
Thank you, sir.
Well done. Good job. All right. So this question says, what's the probability of losing? So remember, we said yeah that if he gets tails, 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 he wins the coin toss and he will kick off 3 times in a row, always. What's the probability of losing all 3 coin tosses? All right, because the question in the beginning said, what is the probability of having the kick off every time if he chooses tails? Then E says, what's the probability of losing if he chooses tails? All right, which means he doesn't get it. He chooses tails 3 times, but he doesn't get it. Okay, every time. All right, so he doesn't get tails, tails, tails. All right. In fact, this is not right. Let's read the question again. Check it out. What's the probability of losing all 3? How do you lose the coin toss? Well, because this guy chooses tails. So what will give him a loss if he gets heads every time? Oh, I've misinterpreted the question, guys. Oh. I'll go with 9 out of 8. So where do we see? Yeah, Sakita, you're right. It's not 7 out of 8. Because look here, let's read it again. What's the probability of losing all 3 coin tosses? Now, because when he flips the coin, he says tails the first time, but he doesn't get it. So what does he get? He must get heads. He tries again the second time. He calls tails, but he loses. What does he get? Heads. He tries a third time. He calls tails, but he doesn't get it. He gets heads. So if you want to lose all 3, it means you're not going to get tails all 3. You see, it lose all 3 if he chooses tails, which means it's got to be heads. He's got to be getting heads every time to lose every time. All right. Okay. Okay. So if he, because each coin toss is separate, it's a separate match. So if he's going to lose all 3 coin tosses and not kick off, he's got to get heads, heads, heads every single time, not tails, tails, tails. All right, which is that one there. Okay. Lauren's like, I knew it. Excellent. So it's 1 over 8. Okay, it's losing, which means you got to get heads. Yes, never doubt your instincts. You're absolutely right. The first thing that comes to your mind is usually the correct one. All right. So I misinterpreted the question. So all 3 coin tosses have to fail, which means he's got to get a heads every time. Lose all 3 every time. It's heads, heads, heads. Okay, I thought he had to get 3 tails in a row and then he wins the kickoff, but it's 3 separate matches. All right, that's a bit confusing. Sorry, guys. All right, let's move on to the next one and get away from heads and tails. We're going to talk about Jane. Jane has a bag containing 50 sweets. All right, so there's a bag in here. There are 17 red, 20 blue, and the rest are green. All right, now I'm drawing lots of sweets. Okay, we're going to pretend that's 17. There's some green ones. I haven't drawn the correct number, guys. Please do not count them. And there are some blue ones. All right, so there's a bag full of sweets. There's red, green, and blue in the bag. Here come the questions. No tree diagram, nothing for this. Let's have a look at it. A, what is the probability that Jane will pick a red sweet from the packet? Now, if you want to work out probability, we need the formula. All right, I'm going to put R for red. We need a fraction. We first got to figure out what's at the bottom of our fraction. Who can tell me what needs to be at the bottom of our fraction? How many possibilities are there when Jane reaches in that bag and grabs one of the sweets? How many total possibilities are there? 50. Yes, you guys have got it. All right. So there's 50 possible things that could happen because there's 50 sweets. So we're going to put 50 there. All right. Now, who can tell me what is the probability that Jane will pick a red one? What's the probability that Jane's going to get a red one? Well, how many red ones are there? Yes. There are 17 red ones. Up there in the question, 50 sweets and 17 are red. So the probability of reaching and picking one of those 50 and it will be a red, it's 17 out of a possible 50 sweets. Okay, 17 out of a possible 50 sweets. Who can tell me? Yes, guys, you got it. You're on the money. Who can tell me what is this as a decimal? You shouldn't even need a calculator, but you can use your calculator. Who can tell me what is this fraction as a decimal? Ah, there we go. All right, because this is the same as 34 over 100. If I double the 50, without a calculator, if I double the 50 and I double the 17, I get 34 out of 100, which is 34% or 0.34 as a decimal. So we need to be able to write this in any format that they ask for. They didn't ask, so the fraction is fine, but we're just practicing any format here. Good job. All right. B. How many green sweets are in the packet? Okay, I'll do this one because it's easy. Well, actually, you guys do it. How many green sweets are in the packet? You guys are writing numbers, Tiamo. How did you do it? What math did you guys do? We need to see the math. Bianca.
So I actually took 50 sweet and subtracted 17 and 20 blue.
All right, very good. Okay, excellent, Bianca. Let's check that out on the calculator. Brackets there. I like to use brackets. You guys know this now. I can hear Bianca's also putting it on her calculator. Yes, good job. Well done. Thank you, Bianca. Excellent. Good job. All right. C. What is the probability that Jane will pick out a green sweet? Okay, so we couldn't do C unless we knew how many green sweets there were. Now that we know how many green sweets there are, what's the probability of getting green? Well, we know there are 50 in total. So it should be 13 out of 50. All right, 13 out of 50. You don't, no, in this case, Lauren, it will work with, no, it won't. It won't work without the brackets. Look here, look at the sum here. Good question. What if I remove the brackets there? I'll move this over. Okay, and I'm sure you're saying to me, Teacher Dale, I would never have put a plus there. I would have put a minus there. That's fine. That's fine. If you're subtracting them both, that's fine. It'll work. Okay. So you must make sure that you subtract them both. I like to use brackets. I'm a big fan of brackets. You don't have to use brackets as long as you subtract them both off the 50. That's fine. All right. So as a percentage, all we got to do is multiply this by 100. So the probability of getting a green is 13 out of 50. To get a percentage, multiply by 100. 26%. You got a 26% chance of getting a green sweet if you put your hand in there. All right, guys, I don't know if you can feel it, but probability is actually not that bad. Compared to when we first started looking at these things, probability is not that bad. In fact, it's quite easy. They try and trick you with the wording, but the sums that we do, the math that we're doing here is not that hard at all. It's just interpretation of the question. Okay. Measurements, yes, which is why we are going to start our exam revision next week, Tuesday, in 5 days' time with measurement. We're starting next week, Tuesday, with measurement revision. All right, let's carry on with the probability. We got one more question here. What is the probability that Jane will pick out a sweet that is not blue? Oh, a brave soul to help me with this one. The probability of not blue. Who would like to try? I'm not going to call out anyone. You must raise your hand, be brave, and tell me if you want to try this out. What's the probability of not getting a blue? So Jane does not like blue. Doesn't want the blue sweets. They taste horrible. So she's thinking, what are my chances of getting anything else but the blue one? I don't want a blue. I want anything but blue. What is that probability? Who would like to try this one out? Any brave souls out there? Anybody?
Somebody.
Somebody.
Anybody.
Oh, brave souls, where are you tonight? Olibacheng's giving us a charm. I was like, uh-oh. Let's think about it. Not getting blue means that we got to get something else. What else is there in the bag? There's red and green. We're getting answers on the chat here. There's red and green. That's not blue. So actually what they're asking here is all the sweets, take away the blue ones, what's left over? Kaklecho is agreeing, also 30 out of 50. Okay, so let's check it out, guys. If we go back up to this question, it says there are 17 red, 20 blue, and we've also now just worked out there are 13 green. All right, we don't want to get a blue, which is 20. We want everything else. All right, so everything else is red and green. Okay, the red ones are 17 and the green ones are 13. So it's the probability of getting these ones, not the blue. All right, which is 30 out of 50. Well done. Well done. Okay, good job, Kaklecho. Olibacheng, well done. Okay, so it's 30 out of 50. All right. Well done. Good job. Okay. Let's have a look. Let's see what's next. There's one more to go. I'm hoping this one's really challenging. I feel like these other ones have been pretty easy. Oof. Here we go. Let's read and see. In a game like Monopoly, a person will roll 2 die at the same time. Answer the following questions. So we're rolling 2 dice. Let's answer the following questions. Draw up a contingency table to represent all the possible outcomes. Oh my gosh. A contingency table. Who can help me explain how to do this? Who can remember how we do this? Is there anyone out there that could help me? Oh, no brave souls tonight, Heik, yeah?
Yeah, no, not a single taker.
No one. All right, here's a table here. Okay, so on the one side, we've got dice 1. I'm going to write here dice 1. And on the other side, yeah, we've got, in fact, it's wrong. My English is bad. Die. one die, two dice. Die 1 and die 2. Okay, so the first possibility, I'll write the numbers here on the left-hand side, and then we'll fill in the table. So they call this a contingency table or a two-way table, all right? So on die 1, we have, I'm going to do it in blue. We have 1, 2, 3, 4, 5, 6. And die 2 is going to be the red. It's 1, 2, 3, 4, 5, or 6. These are the possibilities on each die. So if we go to the first cell over here, this is the first possibility, getting a 1 on the blue dice and a 1 on the red one. So that's 1 and 1. What if we stick with the ones? 1 on the blue and 2 on the red. So I'm looking at this now. Okay. On the one row, I'm just going to keep going on the one row here. 1 on the blue, 2 on the red, 1 on the blue, 3 on the red, etc., etc., etc. Okay, you would just keep filling that in. All right. And then you go to the next row, a 2 on the blue and a 1 on the red, a 2 on the blue and a 2 on the red, etc., etc., etc. Now, Teacher Dale's clever because I remember doing this on Tuesday. So I'm just going to go ahead and steal Tuesday's diagram. Why? Because I can. All right. So here we go. I've worked so hard and I've filled the whole thing in. Sure, look at that. Very efficient. So these are all the possible combinations. Okay. This is the blue dice. I'll write, or blue die. I'll write here the blue die. And on the top is the red die. Okay, and these are all the possibilities when you throw these two dice. All right, we've got our diagram. Let's look at the questions. Who wants to try the first one? Now, guys, don't even look at it. Just be brave and raise your hand. Who wants to try the first one? Anybody?
Somebody.
Somebody?
Anybody?
Anybody?
Somebody?
Is it cold out there, guys? No one's. Noel Boyson, don't you want to help me? Noel, don't you want to help me? No. Yes? No. Okay. Cabello. Shobelo. You want to help me? Come on. You help me, I'll help you. No.
Biela
Okay.
says there's 100% rain. Wow.
Very cold, 100%
But
rain. Yo,
Bianca's back.
Bianca's
So
back.
can I try?
Yeah, of course.
Please do.
Okay.
That's how you
What's the
learn.
question?
B, it says, what is the probability of rolling a total of 6? So you roll 2 dice and you must get a total of 6. Give me an example of what that could look like. You roll 2 dice and you see numbers on the dice and the total must be 6. Give me an example of what that could be like.
How's that?
What 2 numbers could you get that the total of the 2 numbers will be 6?
Oh, 3.
3 and 3. Good. Very good. So there could be a 3 on the one and a 3 on the other. Where do we see that? There we go. 3 on the one and 3 on...
3.
What else? What other combinations will give us
2
a
and
total?
4.
Absolutely. So 2 on the blue, 4 on the red.
1 and 5.
Very good. 4 on the blue, 2 on the red, 1 and 5. Hold on. You're going very fast now. I've got a 1 and 5. There's the 1s and the 5s. What else?
Yes.
Anything else will give us a total of 6?
Total of 6. 4.
I think we got them. We've got them all. If there was a 0, we could say 6 and 0, but there's no zeros on a dice. We've got them all, Bianca.
Yes.
All right.
Yes.
So what's the probability of getting this? They say the question is again, what is the probability of rolling a total of 6 or rolling these combinations? So what must I write?
Mm, I'm not sure. 5
I'll just
over 6. 5 and
very
6. I don't know.
5. You got the 5 right.
5.
How many total possibilities are there in my table altogether?
I got 5.
We got 5 for a total of 6, but all of them in this table, how many are there all together in this table?
I should add them.
You could add them, or you could just say we got 6 going that way, and we got 6 going down this way. We can multiply 6 by 6 gives us
36.
Yep. 36. There are 36 total possible combinations, and you've picked out 5 that will add up to 6. So the probability of getting a total of 6 when you roll 2 dice is 5 out of 36. Bianca, thank you very much.
Thank you, sir.
Well done. All right, come on. So the question again, I will go up to the question. What is the probability of rolling a total of 6? So when you roll the 2 dice, you're always going to see 2 numbers, one number on the one dice and one number on the other. For example, you can get a 2 and a 2, or a 3 and a 5. There's always a combination of 2 numbers when you roll 2 dice. So they're saying when you roll the dice, what chance is there that the numbers you see will give you a total of 6? In other words, when you add them up, they must give you 6. So Bianca said, sir, the combinations that give us 6 are 3 and 3. 3 plus 3 is 6. 4 plus 2 is 6. And 1 and 5 is 6. Now, I see these combinations once here in the middle, but I see a 2 and a 4 there and a 2 and a 4 there, and I see a 1 and a 5 there and a 1 and a 5 there. Okay, so I'm looking at all the possible combinations that when you add them up, you're going to get 6. There were 5 of them, so it's a probability of 5 out of all the blocks in this table. There are 6 times 6, which is 36 blocks. I hope that explains. Okay. Who would like to try 2 and 5, 6 and 1? Okay, so 2 and 5 will give you 7, Sonia, and 6 and 1 will give you 7 as well. So if you add 2 and 5, that's 7. 6 and 1 gives you 7. You need to get a total of 6. So when you add the numbers up, you must get an answer of 6 only. That's what they're looking for. So 2 and 5 will give you 7. 1 and 6 will give you 7. If there was a 0, we could say 6 and 0, because 6 plus 0 is 6. But there is no 0 on a dice. So we only have these ones to work with. Okay. All right. A brave soul for question C. A brave soul for C. Guys, this one's easy. Have a look at C. Read it there. If a person needs a total of 7, when they roll 2 dice, a total, so you add it up, you need a total of 7. What's the probability? Oh, is that what Sonia's doing? She's answering the next one. I've just realized now, Sonia's answering the next one. She's answering question C. Ah, Sonia, you're too fast for us. All right, where do we get a total of 7? 3s and 4s. 2s and 5s will give us 7. 6 and 1 will give us 7. But there's a 3 and a 4 here, a 5 and a 2 here, and a 6 and a 1 here. All right, so the probability of getting a total of 7, there are 6 of them out of the total of 36. Yes. Yes, Sonia, well done. And I understand now why you wrote that. All right, let's try the next one. Guys, this is too easy. Probability is easy. What's the probability that a person will roll a double 5? Oh, ladies and gentlemen. What is the probability of getting 5 and 5 on your dice. Everyone should be typing in chat now. What's the probability of getting a 5 and a 5, guys? Everybody should be typing. Everybody. There are a total of 36 possible combinations. There are 36 possible combinations. What's the probability of getting a 5 and a 5? Yes, everybody should be putting in chat. Chat should be filled with that answer. You only see it once. There it is. There's 5 out of 5. Sorry, 5 and 5. So you only see that once out of 36. Yes, well done, everybody. Just to check that you're all awake and you remember, question D's answer. Please, can you give it to me as a percentage while you guys still got your fingers out there and typing? Question D, can I please have that answer as a percentage? The calculator should be busy working now. 1 out of 36. What is that as a percentage? The screen should be filled. Chat should be filled with the answer again. Oh, guys, what is that as a percentage? 1 over 36. What is that as a percentage? Come on, everybody, we're getting different answers here. Very interesting. I see 2.78, 2.7. Getting all kinds of different answers. I love it. Let's check. 1 over 36 times a percentage. I'll just say times 100. 2.777778. So 2.778. I'm going to write this whole thing down. What is that as a percentage? Round it off to 2 decimal places. So we have to look for the second decimal. There it is. The 7 is on the second decimal. Will it change? Yes, it will. It'll become 2.78%. So your chance of getting a 5 on a dice is very, very small. Very, very small. Unlikely. All right. We got E. What is the probability of rolling a total that is greater than or equal to 9? Okay, we're going to skip that one for now. We're going to go straight to the last one because we're running out of time. In the game of Monopoly, what is the probability of rolling a 1? Remember, we're always rolling 2 dice here. What's the probability of rolling a 1? Yes, you multiply Bianca by 100. What's the probability of rolling a 1, guys? Now, again, they got to be specific in the question. What's the probability of rolling a 1? In other words, I think they're saying we're going to see a 1 on any of the dice. They did not say a 1 in total, hey? They didn't say 1 in total. That's something different. What's the probability of rolling a 1? Seeing a 1 on your dice. Oh. What's the probability of rolling a 1? Getting a 1 on one of your dice? Ah. Where do I see a 1 on my dice? Well, this whole row here, there's a 1. The blue dice will be 1. And this whole row here, or sorry, column here, the red dice will have a 1. Nowhere else would you see a 1. All these other combinations, there is no 1. So I'm interpreting the question like this. What's the probability of rolling a 1? Getting a 1 on one of these dice. Okay, there we go. So let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Don't count that one twice, eh? Just count it once. All right. So the probability of rolling a 1, 11 out of 36. Okay. All right. Ladies and gentlemen, I hope you see that probability can be very easy. So the biggest thing here is to find out what your total is. How many total possible outcomes do you have? And then the questions that you're going to get in the exam will be specific about all kinds of different possibilities. And then you just put it into the fraction. You know how to change it into a decimal and a percentage. All right. For decimal, just put on the calculator, press equals. For example, if I have, let's say, 15 over 36, what is that as a decimal? Press equals, press the ST button, there it is. What is it as a percentage? Just times it by 100, and you get your percentage. Okay, so changing between fraction, decimal, and percentage is very easy. It's building the fraction. That's the only thing you have to worry about. Yes, doubling, that is the challenge. The math is easy. It's interpretation of the question, which is why in math literacy, you've got to practice questions. Now, from next week onwards, we are going to practice exam questions. So for revision, I'm only taking exam questions to see how they write the question. Get used to that, because I know every single one of you can do the math, but you still may struggle with interpretation. All right, it's math literacy. Literacy is reading and understanding what is written. Okay, so there's two parts of the subject. There's the math, which is quite easy. The literacy can be tricky. So you need to practice that skill, interpreting the text of the question. And that comes purely with practice, and it comes purely with doing past papers and exam questions. So we're going to start that next week. We've got 3 weeks of it, of just exam questions. And we're going to learn what are they asking for in the question. That's the literacy part of math literacy. The math I've taught you, it's the literacy part that we're going to practice next week. So I hope to see you guys all on Tuesday for math revision.